Hi everyone, welcome back to this week's update for our Q-learning survey project. This week's theme is from discussion to infrastructure and verification. In previous updates, we talked a lot about the paper's content, the taxonomy, benchmark coverage, protocol metadata, and different Q-learning families. This week is slightly different. The main progress is not the new technical section, but the infrastructure that makes the whole project easier to collaborate on. We now have a working local build pipeline, an updated README, and the beginning of a systematic claims verification process. The main message this week is that the project moved from discussion into infrastructure and verification. There are three pieces of progress. First, the build pipeline now works locally. Both the main TAI draft and the supplement can be compiled to PDFs. Second, the README has been updated. This is important because contributors need to know where things are, how the draft is organized, and how to build the paper. Third, we started the claims verification process. This means we are going through the manuscript claims one by one and checking whether each claim is correct, supported, and internally consistent. The key idea is that reproducibility is not only about experiments. For a collaborative research paper, the writing process also needs to be reproducible. The TAI draft is written mainly in Markdown files inside the draft-tai folder. The build system takes those Markdown sections, converts them through Pandoc, then uses LaTeX to produce the final IEEE style PDF. After debugging several dependency issues, both outputs now compile successfully. The main paper is generated as main.pdf, and the supplement is generated as supplement.pdf. This is a big practical milestone. It means that the draft is no longer just a collection of Markdown files, it is now a working paper pipeline that can produce the final review artifacts. This matters because a collaborative paper needs a reproducible writing workflow. If only one person can build a paper, then collaboration becomes fragile. Other people may be able to edit text, but they cannot easily check whether their changes compile, whether late tables render correctly, or whether references will work. Now, contributors can edit individual Markdown sections, rebuild the PDF locally, and catch errors later. It also makes review easier because the source files and the compiled outputs stay connected. So the practical benefit is that the survey now becomes easier to edit, easier to build, easier to review, and easier to distribute across the team. The build requires several moving pieces to work together. We need things like Pandoc, XC LaTeX, BibTeX, Node.js, and Mermaid rendering tools. One lesson was that Ubuntu's default Node.js version was too old. The Mermaid rendering script used more than JavaScript syntax, so Node 12 failed. Upgrading to Node 20 fixed that part. Another lesson was that the Pandoc version also mattered, especially because the draft used LUA filters. We also found that the Mermaid-related packages should be installed as local dependencies inside the draft folder rather than only installed globally. The result is that the setup is not much clearer and can be documented for future contributors. And the README was also updated. It may sound very simple, but it's actually important for onboarding. The README now explains the repository layout, the TAI draft section map, the Python experiment setup, and the common commands people need. It also explains the main editing workflow. Go in draft TAI, edit the relevant Markdown section, then rebuild the main paper for the supplement. The README turns the repository from a collection of files into a workflow that contributors can actually follow. Now, the second major direction this week is claims verification. Inside draft, we have a file called claims-verification.md. This file lists claims on the manuscript that need to be checked before submission. The goal is to separate verification from rewriting. If a claim is correct, we mark it as checked and add initials. If a claim is unclear, unsupported, or wrong, we leave it unchecked and add a note. Later, after enough rows have been reviewed, we can do a separate fixing pass across the draft. This helps us avoid randomly rewriting the paper before we know exactly what needs to be fixed. And so the ledger separates claims into different types. Citation claims are about the author names, years, attributions, and whether a method description matches the cited paper. Numeric claims involve counts, benchmark numbers, years, or performance values. Experimental claims come from our own tableau experiments, so those need to be checked against scripts and result files. Snapshot claims are repository coverage facts that are true at a particular audit point. Synthesis claims are different. They are our own interpretive claims, so they cannot be checked by only looking up a citation. we need to judge whether the framing is defensible and internally consistent. This distinction is helpful because different claim types require different verification strategies. And so let's give a simple example. One row checks whether the application citations in the introduction match the claim application areas. For example, the citations are Mini 2015 and Bellarmine 2013, which match the DQN and arcade learning environment. For robotics, Sidebars 2021 matches deep reinforcement learning for robot training. For autonomous driving, Imamada 2024 matches safe reinforcement learning for autonomous vehicle control. And so this row can be marked as verified. Starting with rows like this because it's useful because they are relatively concrete, we can build momentum before moving to harder synthesis claims. And finally, the next steps are very clear. First, we just commit the README updates and local node dependency setup. Second, we'll make sure no modules are not committed to Git while keeping package.json and package.log.json so others can reproduce the setup. Third, we will continue checking rows in claims-verification.md. For claims that are questionable, we just add notes. Then later, we'll do a dedicated fixing path for citation issues, year mismatches, wording problems, and evidence gaps. After edits, we will rebuild both main.pdf and supplement.pdf. So overall, this week's message is that the project is becoming more serious as a collaborative research writing workflow. It's easier to build, easier to review, and easier for multiple people to contribute to. And that's everything. Thank you for listening.